Good afternoon, class. We are looking at Chapter 2 review, limits and derivatives. Here's the exam one that goes from 2.1 to 2.8. We are going to cover 2.7, derivatives and rates of change, as well as 2.8, derivatives as a function. All right. If you have 2 points, given y equals f of x, and point A, comma, f of a, the slope of a secant line PQ, there's another point Q with coordinates x and f of x, which represents the average rate of change. So M of PQ is rise over run, delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And there are different ways of writing it. For example, the way it's given here, we would write f of x minus f of a over x minus a. And what I want you to notice, these two are identical. It's the same thing. Rise over run. Slope of a line. Elementary algebra, we know how to find it. When we go with this format, take a look. Instead of over here, we go with f of x. Let's call this distance h. By the way, over here, this is the rise f of x minus f of a. This is the run x minus a. Over here, this distance, we're going to call it h. The run is h, and therefore, if this is a, this is a plus h. So for q, the coordinates are a plus h and f of a plus h. So if we use now this one, f of a plus h minus f of a for the top, and the bottom is a plus h minus a plus h minus a gives us h. And you may recall this or this one from college algebra, pre-calculus as the difference quotient. If we give this the name b, therefore this becomes f of b, and now here f of a b minus f of a, x minus a becomes b minus a. What is my point? They are all the same. Different texts may use different variables. They are all basic rise over run. Now, the tangent line is the limiting position of the secant line PQ as Q approaches P. In other words, if you take a look at the graph, this is one point Q. As we move towards the first point P, the lines, the blue lines that are called the secant lines, they are moving towards the red one that is the tangent line. That's the idea. Now, slope of a tangent line, also known as instantaneous rate of change. M of tangent line is the limit of M of PQ as Q approaches P. So as Q approaches P. Or if you look at this one, as X approaches A. Or if you look at this one, as H approaches 0. Normally, these are the two definitions we use. So f prime of A is limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h as h approaches 0. That represents the slope for a specific point. Now, we are interested in finding the tangent line. So lines, we have the standard form, ax plus by equals c. Point slope, y minus y1 equals m times x minus x of 1. These are all elementary algebra. Slope intercept y equals mx plus b. We normally solve for y to get there. So with that being the case, look at this point slope. This point, if I'm going to use this point, which has coordinates a and f of a, then I'm going to say y minus y1 becomes y minus f of a equals m. M is f prime of a. X minus x sub 1. X sub 1 is a. Do I have to memorize that? No, I just use the point slope. It's just as good. It's the same formula. It comes from there. And now, if you look at this case where we have a couple of points and this one has coordinates x and f of x, okay. and we move to the right by h, okay? And now this point has x coordinate x plus h, the y coordinate f of x plus h. So take a look at f of x versus f of x plus h. This is the rise, this is the run. And so normally we use that one, but with x, and it's a general differentiation formulas. F prime of x is limit of f of x plus h minus f of x over h as h approaches 0. All right. We want to find the derivative of the function. And again, as many of you know that you can do that using formulas in a split second. For this exam, you must use definition. So we are going to use definition. Okay. So f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. And this is the difference quotient you have to work out and simplify. So f of x plus h means 5 times x plus h plus 1 minus this thing over h, and take a limit as h goes to 0. So 5 times x plus h plus 1 minus 5 x plus 1 over h. All you have to do, simplify the fraction, and everything becomes clear. And this is 5x, this is 5h plus 1 minus 5x minus 1. So just distribute the 5. You notice that you can drop the 5x with negative 5x. You can drop the 1 with negative 1. And so you're left with 5h over h, where h can be dropped. And this limit is simply 5. Now again, some of you may remember the formula, the answer is 5. But if you're asked to do this, you have to do it by definition for this section. We want to set this up according to this formula. F prime of x is the limit of f of x plus h. F of x plus h is 2 over x plus h minus f of x, that means this, over h. So this is the part I hope everybody can see. This is 2 over x plus h. By the way, if you plug in, you end up with indeterminate form, whether it's here or here. Right now, if you plug in h equal to 0, you get 0 over 0. And as you recall, this is a complex fraction. So the technique is LCD. So you need LCD because this is a complex fraction. So what is the LCD? Simply the product of these two, x and x plus h. So you're going to multiply and divide by it. So what happens to the denominator? Nothing. Just write it as a product. What happens when you multiply this one by this one? X plus h goes away. 2 times x. When you multiply it by this one, x goes away, minus 2 times x plus h. I'm assuming everybody is comfortable with algebra, fractions, LCD, complex fractions, things of that nature. And so 2x minus 2x minus 2h, 2x and minus 2x cancel each other. So the numerator has nothing but negative 2h. H and h cancel each other. Now if I plug in 0, the denominator is x times x, or x squared, negative 2 over x squared. So I did this in a general format, although later on I will show you also how to find f prime of a, but you can always use the general format on those and replace it accordingly. We want to find the equation of a tangent line for the function f of x equals square root of 3x plus 1 at x equals 8. First, notice they gave us x, sometimes they give us x and y, but even if they don't, when you plug in, it gives you the pair. So The two things you need is a pair you can plug in and the slope, which means you find the derivative and then you plug in. So you can find f prime of 8 or find f prime of x first and then replace it with 8 to find the answer. So let's do that. So I want to get the f prime of x using this limit. So the limit as h approaches 0. F of x plus h means square root of 3 times x plus h plus 1 minus just write this one over h. So please understand this is f of x plus h, and I hope nobody has any problem with that. So now, if you plug in, you get 0 over 0 plus. So what is the technique? Anybody remembers what technique we use? So if we plug in, we get 0 over 0. The technique we're going to use is called what? Anybody? So if we plug in, we get 0 over 0. The technique we use is called conjugate. So you change this to a plus sign, you put it at top and the bottom. And the reason you do that, because the product of these two is a squared minus b squared. Therefore, when we multiply this one by this one, this comes out minus this comes out. Each one comes out of the radical sign. And the denominator, you keep it as a product, everybody. So all you have to do, simplify the expression and then take a limit. 3x plus 3h plus 1 minus 3x minus 1. So what happens? These two cancel each other. These two cancel each other. So the numerator has only 3h. You can drop the h. This is what you have now. You drop the h and you replace the h with 0. You drop the h, you drop the h and replace the h with 0, you get rid of the limit sign. And as you can see, we have two of this now. 3 over 2 square root of 3x plus 1. Now, we need two things. We need a pair x comma y, and we need the slope. To find the pair, we plug in x equals 8, 3 times 8, 24 and 1 is 25. So 8 and square root of 25, which is 5. So this is the pair. To find the slope, we get f prime of 8. So if I plug in 8 here, I get 24 and 1 is 25. So this is 5. 2 times 5 is 10. 3 over 10. So plug it into this. That gives you the slope. So we have the pair 8 comma 5. And we have the slope 3 over 10. So y minus y1 equals m times x minus x sub 1. So y minus 5 is 3 over 10 x minus 8. Elementary algebra. The rest is elementary. Just distribute 3/10 of an x, and then 3/10 minus times minus 8 becomes minus 24 over 10 or minus 12 over 5. We are going to move the negative 5. As you know, 5 is 25 over 5. With negative 12 becomes 13 over 5. And we're done. The only thing I want to add, class, is this. This pair, 8 comma 5, belongs to the original function f of x. Also, it belongs to the tangent line at the point of tangency, right? That's their point of intersection. So 8 should work here too. So if I put the 8 here, because that's what we did, I want to explain what it means at the end. I get 3 times 8, 24 over 10, which is 12 over 5 with 13 over 5 gives you 5. So check. What it does, it says, when you use this one as the slope, this one as a pair, your calculation is right here. It doesn't mean that the slope that you came up with is correct, because those are different steps. But this means that 8 and 5 works here, that assuming this is the correct slope, and this is the point you're using, you haven't made a mistake in these steps. That's the meaning of it. All right, the graph of a function is given. We want to use it to sketch the graph of the derivative f prime. To do that, I want to explain a few things to everybody. Note, relative max and mean happens when f prime is 0. So peaks and valleys. This one is a mean, this one is a max, this one is a mean. So you have, if you were to draw a tangent line, would be a horizontal line. Increasing, which looks like almost positive slope, f prime is positive. Decreasing when f prime is negative. Remember, f prime is the concept of a slope for a line, okay? So with that being the case, let's write all of the important parts of this guy. And what we notice, if we call this point A, you can draw a line segment which is horizontal. The slope is 0 here. So this point corresponds to 0 on the graph of its derivative. Same thing as B, same thing as C. And never mind this one. I'm going to discuss that at the end. This is decreasing. This is decreasing. F prime is negative. Increasing. Increasing. F prime is positive. So decreasing. F prime is negative. Increasing. F prime is positive. So again, I'll show you a better graph, but just a rough sketch so you see how that thing works. If I were to graph this, I would say, okay, this corresponds to 0 here, right? This corresponds to 0 here, right? This is, by the way, f prime. This is f, right? And just those three. Then I look at this part, say it's what? Decreasing. This part, decreasing means f prime is 0, negative. If f prime is negative, it must be below the x-axis. So somewhere here. Okay. Now I may not know exactly how it looks like, but then I go to the next part. This part is increasing. From A to B is increasing. From A to B, f prime is positive. From A to B, this is above the x-axis, but the reason it has to come back because it's 0 here and 0 here. So it goes above, but it has to come back. I may not know how far it goes. And the same thing happens here. This is negative, so this goes down. Again, how far it goes, I may not know, but it has to come back up to 0 according to this. So goes down and becomes 0. And then here, over here, it is positive, it goes up. And again, I may not know how it goes up, okay, but it goes up. Now, one might say, okay, what happened here? They picked a point and they made sure the x and y was very clear, 5. And then they draw the best tangent line they could, and they picked another point and they calculated the slope, roughly is 3/2. So this should correspond to the point with coordinates 5 and 3/2 on the uh, graph of this function, so somewhere here. Now I'm going to clean up the mess and show you the actual answer. Okay, see, A corresponds to A prime, B to B prime, C to C prime. This corresponds to 5 and 3/2. 3/2 is 1.5, by the way. So this is decreasing below the x-axis. This is decreasing below the x-axis. Increasing above the x-axis. So this is a rough sketch of it. Let's look at a couple of examples. Fairly simple. Starting with a line. And it can't get any easier than that. Anytime they ask you to graph the function, the derivative of a function, as it is the case here, the graph of a function f is given, use it to sketch the graph of the derivative. If it's a line, find its slope. Whatever the value of the slope is, a horizontal line with that number. If the slope is 10, y equals 10. If it's -8, y equals -8. That's all you have to do. So pinpoint 2 points. This is 0, 0 clearly. And this one is 1, 3. I want to make sure you understand that this is 1, this is 6. So the scale along the x-axis and y-axis, they don't have to be the same. And they are not here. And rise over run, 3 minus 0 over 1 minus 0. So the slope is 3. I'm assuming everybody can calculate that. So basically, draw the line y equals 3. And that's your answer. For a line, you're done, everybody. Very simple. What about this one? Again, let's start with easy points. This one and this one, those 2 points are easy. This 2 points. That means they correspond to 0. If I were to draw on the same set of axes, those would be the answers. Those are corresponding to that. And let me see. I want to okay. Let's reuse that. So this portion, everybody, f prime is positive. This portion, f prime is positive. This portion is decreasing. F prime is negative. So what happens is, let's see, let's use a blue one. For this part, which is positive, it corresponds above the x-axis. For this one, also above the x-axis. And in between, let me use a red one. It's below it. So this is the graph, of course, much better. The only thing I want to maybe clean up and add this part, f prime is negative. Okay, it's pretty straightforward. And again, those are the points corresponding to horizontal tangent lines, peaks and valleys. What about this one? This point is flat, and actually sometimes they use it with arrow. So that corresponds to 0. And this part, this portion f prime is positive, so they look like that. Different color. This decreasing. This is increasing. So looks like that, something like that. So here's the graph, and of course, let me again clean up the mess and write down. Prime is positive and negative, so we can distinguish between the two. It's a rough sketch. Now, how can a function fail to be differentiable? Well, when we have a sharp corner, when we have a discontinuity, and we have a vertical tangent line. A corner or kink. The graph of f has no tangent line at this point. The left and right limits are different. So the point is, where do you put that? So the limits are different. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. The limit of absolute value of f prime of x as x approaches is infinity, meaning the graph of function f of x has a vertical tangent line at the point a comma f of a if the limit of f prime of x is negative infinity as x approaches a, or it's positive infinity. Both sides have the same result, and positive or negative infinity. Cusp, when the limit of f of x, f prime of x as x approaches 0 from the right and 0 from the left are different. One is infinity, one is negative infinity. And it looks like a sharp corner, but it's slightly different because if it continues, becomes vertical, whereas this one, if it continues, class goes this way and this goes this way. Okay, it can continue that way, it can continue that way, but this one, both of them continue down. When the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a and f of a. If the limit of f prime of x as x approaches a from the right is infinity, and the limit of f prime of x as a approaches a from the left is negative infinity, or vice versa, both sides do not have the same result. So that's the difference between a vertical tangent line and a cusp, but they're similar. Okay, let's take a look at this simple example. And the question is, the graph of a function f is given where and why the function is not differentiable. So clearly, at x equals 0, there's a discontinuity. And at x equals 3, it's a vertical tangent line. Now, one thing I want to make a point of, if you think it's a sharp corner, I'm not worried about that too much, but you may see that this appears to be going up. However, if you look at this one, obviously at -1, we have discontinuity. At 2, we have a sharp corner. Why is this a vertical tangent line and here's a sharp corner? If I continue on this one, it goes this way and this one goes this way. They don't go down, both of them. Do you follow what I'm saying? In other words, they go to two different directions, okay? This seems that both of them are going up. You don't have to worry about it too much, but at least that's the concept. All right, the graph is given, and we want to use it to sketch the graph of its derivative f prime, everybody. So we want to do and f prime. Okay, let's see what we can do here. So first and foremost, understand we are dealing with 1, 2, 3, 4 line segments. If you assume this was a complete line, all you had to do, find the slope for this one. Find the slope for this one, and whatever the slope is, y equals that is the answer. So we have to do that for all 4. So let's assume we have the following coordinates: -3, 1, -1, 0, 0, 1, 1, 0, 3, 1. So we can calculate the slope for this one, for example, 0, -1, -1, -3, and the slope becomes -1/2. I'm assuming nobody has any problem finding those. If the slope is m equals -1/2 for this one, I hope you recognize this one is +1/2, right? Or you can work it out. 3, you can say 1 minus 0 over 3 minus. This one has a slope m equals 1, and this one has a slope m equals -1. Again, you can work them out with the formula, okay? All right, so let's look at this one. If m equals -1/2, if this one was a line that continued indefinitely, this would be the answer, y equals -1/2. It doesn't continue indefinitely. It stops here. This is a sharp corner. So this is a hole. Do you understand that? Because this is a sharp corner, that's a hole. Now for this one, you go with 1, and it has sharp corner here and here. So 2 holes. This one -1, and again sharp corner, so on and so forth. Let me clean up the mess. So y equals -1/2. This works for this one, and it stops here, and it has a hole because this is a sharp corner, everybody. So we have y equals 1, y equals -1, y equals 1/2, and we are done. Pretty straightforward, everybody. Find the limits of the square root of 1 plus 4x to the power of 6 over 2 minus x cubed as x approaches -infinity. So the technique involved is interesting here. In the denominator, you have x cubed. This one, the square root of x to the power of 6 is somehow x cubed. Of course, you got to pay attention to the sign. I'm going to discuss that. So I can take x to the power of 6 out and keep it inside. So if I factor x to the power of 6 out, this becomes 1 over x to the power of 6. This becomes 4. Now, pay attention to what I want to tell you. In case of the limit as x approaches infinity for x larger than 0, square root of x squared is not x, is absolute value of x. But for x larger than or equal to 0 becomes x. And in case of x approaching -infinity, or x less than 0, absolute value of x squared, which is absolute value of x, is minus x. So please understand what I am telling you. When x goes to infinity, absolute value of x is the same as x. But if it goes to -infinity, absolute value of x is the opposite of that. And that's exactly what happens here. You can't take out x to the power of 6. When you take it out, it becomes minus x cubed because this is approaching -infinity. Okay? X cubed is the square root of x to the power of 6 when x is positive. But if it's negative, it's minus of that. Okay? And this is minus x cubed. So pay attention to how you take this out. Because of this, that it's negative, it creates this negative sign. If this was positive infinity, it wouldn't. Now, we divide the top and the bottom by highest degree term in the denominator, which is x cubed. Divide everything by x cubed. When we divide everything by x cubed, let's see what happens. In the numerator, this x cubed goes away. And we have minus the square root of 1 over x to the power of 6 plus 4. This one becomes 2 over x cubed, and this one becomes minus 1. Since x is approaching infinity or minus infinity makes no difference. This goes to 0, this goes to 0. So we have minus square root of 0 plus 4 over 0 minus 1. This is 2 with the negative is minus 2 over minus 1 is positive 2. And that's how you end up with the final answer here. What about the limit of x squared over the square root of x to the power of 4 plus 1 when x approaches infinity? And I'm going to remind you of what I told you in the previous page. Therefore, the technique we're going to use, we're going to take the x to the power of 4 out. And so the top doesn't change. This becomes x to the power of 4 times 1 plus 1 over x to the power of 4. X is approaching infinity, so it just comes out as x squared. So x squared is square root of x to the power of 4 when x is positive. It so happened, even if it's negative, it's still x squared, because when you raise it to the second power, if the power is even when it comes out, it's always positive. If it's odd, you have to pay attention as we did with the previous page. So this is approaching infinity. This comes out as x squared. Now you can drop these two and the numerator changes to 1. And now when you plug in, I hope you realize this becomes 0. And the answer is 1. We want to find the derivative going through the definition, where f of x is 7x squared plus 4. So f prime is the limit of f of x plus h minus f of x over h. So this and this is easy. Just find f of x plus h, which is 7 times x plus h squared plus 4. So this part. Then minus, here's f of x and then over h. So what happens next? We are going to distribute here, and to distribute first we have to write x plus h squared is x squared plus 2xh plus h squared. When we distribute the 7, we get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4. So all I'm doing, class, here, all I'm doing is algebra. Plugging in, simplifying. So notice 7x squared cancels out minus 7x squared. 4 cancels out negative 4. So what are you left with in the numerator? 14xh plus 7h squared, and I can factor out 7h, but I just want to take the h because h is approaching 0. This is going to be a trouble. Again, I can take out 7h, but I just want to take the h. So this goes away. So you have 14x plus 7h. Take a limit of that. And notice I haven't lost the limit sign. Now that I plug in, I get 14x plus 0, or simply 14x. Again, this can be done in a split second using formulas. We are using definition. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? This is the average velocity class. So in this case, it would be this formula, which gives you v, in this case, s of 4 minus s of 2 over 4 minus 2. Let me explain to you the meaning of it one more time. If you're doing 100 miles over the course of 2 hours, then your average speed is 50 miles per hour, which means on the average, not at any given time. Okay, we are given 2 points in time. So even if they say average velocity or they don't, it means average velocity. So plug in 4, 2 times 4 squared minus 5 times 4 plus 4d minus, plug in 2, 2 times 2 squared minus 5 times 2 plus 4d, and simplify. So to simplify, this is 16, so we have 2 times 16, 32, minus 20, plus 4d. This is 4, 2 times that is 8, minus 10, plus 4d. So 32 minus 20, 12, and 40 is 52. 8 minus 10 plus 40 is 38. So 52 minus 38, which is 14 over 2. 7 feet per second. Please understand this is delta S over delta T. Change in S over change in T. Change in distance over change in time, and units of distance over the units of time. What about the instantaneous velocity at 4 seconds? I want you first notice the difference between the two. This one gives you 2 points in time. This gives you only 1 point. Even if the instantaneous is missing, that's what it means, which means differentiate. So we're going to use this formula. And we want at 4. So we're going to replace the a with 4. Again, we are using the definition for now. So what is s of 4 plus h? Plug it in here. 2 times 4 plus h squared minus 5 times 4 plus h plus 40 minus s of 4. I can calculate it, but I've already done that here. So I'm going to use s of 4 as 52. Okay, everybody. Four plus h squared. As you know, squared is 16 plus 2 times 4 times h, 8h plus h squared. And now if I multiply this by 2, I get 32 plus 16h plus 2h squared minus 20 minus 5h plus 4d minus 52. Now, if you add up 32 minus 20 plus 4d minus 52, they add up to 0. (16h) and minus 5h is 11h. So in the numerator, we have 11h and 2h squared. We take the h out. So we can drop it from here and here. And now when you plug in 0, you get 11 feet per second. Please understand this is ds dt. Delta S delta over delta T means the average rate of change. This means instantaneous rate of change, okay? But the units are the same because of this, okay? The units are the same. Find an equation of a tangent line to the parabola y equals x squared at point 1 and 1. And we want to stick with this method. I want to show you also how to find f prime of a. Although you can find f prime of x and then plug in 1. You can do that, but just this method. First, notice if you want to stick with that, a is 1 and the function is x squared. We can use one of those, and in fact, I'm going to use both for practice. So I'm going to stick with the first one. And I'm going to replace the a with 1 because I want f prime of 1. So m or f prime of 1 is limit of f of x minus f of 1 over x minus 1 as x approaches 1 by this definition. And replace the f of x with x squared. F of 1, you can evaluate it or just it's given. Please understand, again, all they have to do, give us the x coordinate, we can plug in to figure it out, and that's 1. Again, you all know this is 0 over 0. You need to do factoring, and you've done factoring a lot. X squared minus 1 factors to x minus 1 times x plus 1. And you can drop these two. And if I plug in 1, I get 2. I get this slope. Point slope, y minus y1 equals m times x minus x of 1. So y minus 1 equals m2 x minus x of 1, which is 1. And we get y minus 1 equals 2x minus 2. Change this to a plus 1, and that's the tangent. You're done. I want to explain two things. Number one, this pair belongs to the original function. Also belongs to the tangent line. If you plug in 1, you get 1, which means we didn't make a mistake here. It doesn't say that this is right. It says, assuming this is right, we haven't made a mistake here. The second thing is that for practice, I want to show you the second method, where a is 1. Second method for practice. So what is f of 1 plus h? 1 plus h squared. What is f of 1? We already have it, so we don't have to do much. Raise this to the second power, because we want to simplify this fraction. This is 1 plus 2h plus h squared. 1 and negative 1 cancel each other. We can factor out the h. H and h cancel each other. And if you plug in 0, you get 2. As you can see, they are identical. And that's the idea. I wanted to show you how to find the slope with the limit of f of x minus f of a over x minus a as x approaches a, and also with limit of f of a plus h minus f of a over h as h approaches 0. Both of them must give you the same answer. You don't have to do both ways, but now we've been exposed to that. And that should actually take care of the business we had in mind. I want to look at one more question, class. Again, with the purpose of using both methods by practice, and understand we want to find the equation of a tangent line for this function f of x equals square root of x at this pair 16 comma 4. Remember, if you plug in 16, you get 4. So if they told you x equals, I don't know, 100, when you plug in, you get 10. So we are going to go with one of those, for example, this method. Of course, a is 16 and f of x square root of x. We're going to replace the a with 16. And so we are going to plug it in here. We get square root of 16 plus h. This one, we already know the answer is 4. But I'm going to keep this as a square root of 16 on purpose. Here's the reason. Class, we know square root of 16 is 4. And it's number 16 is a perfect square. Easily comes up. But what if it were 17 or 20 or a number which is not going to come up? You leave it as that. No matter what, at this point, you should recognize it's 0 over 0. And the technique is the conjugate. So multiply by the same thing with the plus sign and divide by it. These two don't change. But remember, this is now a squared minus b squared. This comes out minus this comes out. So what you are looking at, the result here is this for the numerator. And so 16 and minus 16 cancel each other. The numerator has h, which cancels out the h in the denominator. If I plug in 0, I get square root of 16. So this is 4 now. This is 4 now, and I get 1 over 8. And all I have to do is the point slope. Use the point slope, y minus y1, because m times x minus x of 1, meaning y minus 4 is m1 over 8, x minus 16. When I do that on the right side, I notice I have 1 over 8 of x minus 16 over 8 or 2. I use the negative 4 on the other side, becomes 4. And that's the final answer. And again, notice if I plug in 16 here, I get 2 plus 2, which is 4. So y equals 1/8 of x plus 2 is the equation of a tangent line. We are done, however. I want to show you the second method for practice only. For practice only. Let me clean up the mess. So f of x minus f of 16. So we replace the a here, here, and here with 16. Replace the f of x with square root of x. And if you plug in class, you do get 0 over 0. And again, we need to use its conjugate, which is the same thing with a plus sign here, as well as the denominator. When you multiply these two, you get square root of x to the second power, which becomes x, minus 4 to the second power, which becomes 16. These two cancel each other. And now if I put 16, it gives me 4 and 4 is 8. And I get the same 1 over 8 here that I got here. And that's the idea. I'm just interested in this row. This I'm not going to repeat. And that makes it very nice and easy.